Our next area that we're going to cover deals with sequences and series. We looked at sequences back in chapter 1. Well, now we're going to add series to that. First, reviewing a sequence, it's a collection of terms listed in some order. Each one of those things is considered to be a term. This one is the first term. Here's our second. Here's our third, our fourth, and our fifth. And so if you were to plot points, this would be the coordinate 1, 4. Then you have 2, 12, 3, 52, 4, negative 21, 5, 18. When you're dealing with sequences, the domain would be the natural numbers. So from 1 to 2 to 3 to 4 to so on. Occasionally, you might even use the whole numbers, which would be from 0 on. But most of the time, when you're dealing with a sequence, you're going to start with 1. So here are some sequences. In this first one, you're adding 6 each time. Now back in chapter 1 we did the recursive rule and said a sub 1 is 6 and a sub n equals a sub n minus 1 plus 6. Or no, a sub 1 is 2. Well, we're going to take that and turn that into an explicit formula, and so in this case it would be a sub n equals 6n minus 4. Because if you put a 1 in there, 6 times 1 is 6, minus 4 is 2, which is the first term. Kind of like back when we did something like this and we had to write this sequence in the explicit way, you had to remember this is, since this is a sub 1, you had to figure out what term 0 is. An arithmetic sequence. Okay. This second one here. Here we could add 3, but then adding 3 doesn't get us to that one. So if you multiply by 2 each time, you're going to get from one term to the next. So then a sub n is equal to, and our first term is 3. Now just if you think about this, if you go from 3 to say 24, and why did I pick 24? I'm just going from a different term rather than the next one. You have to multiply by 2, by 2, and by 2, which is 2 to the third power. Well, what term is this one? It's the fourth term. And that is one less than it, so it would be times 2 to the n minus 1 power. Now, if you think about that, first term, if you put a 1 in there, 1 minus 1 is 0, and 2 to the 0 is 1, and 3 times 1 is 3. If you go to the second term, you'd put a 2 there, and 2 minus 1 is 1, and 2 to the first is 2, and 3 times 2 is 6. Going to the third term, 3 minus 1 is 2, and 2 squared is 4, and 3 times 4 is 12. And so that particular sequence is defined by 3 times 2 to the n minus 1. Looking at our next one, you have 1, 3, 7, 15, 31, and 63. Well, you're going to add 2, but then here we're adding 4, and here we're adding 8, and there we're adding 16. So it's keeping going up each time. Now, think about this. What is 2 squared? That's 4, and 2 to the third is 8, and 2 to the fourth is 16. And how do these numbers relate to those? Well, these are 1 more, so these are 1 less than those. So it's 2 to some power minus 1. Now think about that. 2 to the second term is 2 squared, which is 4, minus 1 is 3. 2 to the first term would be 2 minus 1 is 1. This last one here, we have 1, 1/2, 1/3, 1/4, so it is 1 over n is the nth term. Some of them may be a little more difficult than, you're just going to have to try to figure them out from there. Then we get into a series. A series is the sum of terms in a sequence. So if this is our sequence, 2, 5, 8, 11, 14, if we take this and add it up, then that becomes our series. And if you add these up, that is 40. Now, when they want you to find the sum of the terms rather than writing it all out, they will use summation notation, also called sigma notation, because sigma is a Greek symbol, Greek letter of the alphabet. It is that. This symbol means add up all terms. When you see the sigma symbol, there will be something down here. That would be your starting term. You will also see something up here. That is the ending term. And then here will be some type of an expression. So if we go back to our sequence here of 2, 5, 8, and 11, and 14, and we say that this is sequence A sub n equals, there's 5 terms. So when we write the sequence, the summation notation, we would say I equals 1 to 5 A sub I. So this says add up all the terms in the sequence A where you're going to go from term number 1 to term number 5. So in this case, because we're using these terms, this would be 40. Now, something like this. Says I equals 2 to 4 for A sub I. So that means we are going to take the A sub 2 through A sub 4. So 2, 3, and 4, and add those up. 5 and 8 is 13 plus 11. That is 24. This one here says we have to take A sub I and add the first term through the third term. So we're going to take 2, 5, and 8 to get 15. Now other times they may not give you the terms and instead give you an expression. So this says add up the terms from terms 1 through term 6 where you have 3i plus 4 as your equation. So we would have to take 3 times 1 plus 4, and that is 7. And then 3 times 2 plus 4, which is 10. 3 times 3 plus 4, which is 13. 3 times 4 plus 4, which is 16. 3 times 5 plus 4, and that's 19. And 3 times 6 plus 4, which is 22. And then take these and add them all up. And you have 10 and 16 and 25, 26, 27, and carry the 2 and 2, 3, 4, 5, 6, 7, 8. So sum of the terms from 1 to 6 of 3i plus 4 is 87. Here we have the sum of the terms of I squared. So 1 squared is 1, 2 squared is 2, 3 squared is 9, and 2 squared is not 2. 2 squared is 4. And then we add those up to get 14. And so the sum of the first 3 terms of I squared is 14. And that is everything for this particular section. You will now be getting a worksheet with the assignment.